Welcome back to my channel. Today we'll keep talking about Alibaba's middle offices. Today's topic is Business Middle Office or BMO. My name is Johnny and I work for KPMG Shanghai office. I was nominated as Microsoft MVP since 2014 and I'm also Alibaba certified expert. Okay. As per Alibaba's definition for digital transformation, an enterprise should build its own cloud environment for better resource scalability. I think no matter it's on-prem data centers or it's hosted on cloud service provider, you should have one. And it makes easier for you to absorb IoT data for richer information channels in order to build big data platform. Here, this is the cloud operating system. It's the big data platform for the enterprise. This big data platform can harvest or help us to harvest a more insightful business view. Moreover, enterprise should provide multiple access channels to customers, especially in the world pandemic moment now, right? Alibaba refers to this architecture, this four-layer architecture, as the four enabler of digital transformation. In Chinese, it's called 四化, which reminds me of the four modernization goals at the beginning of China's reform and opening up strategy in late 1970s in the past century. It's also called 四化. So it's the same terms here. So through this, you can see Alibaba's ambition. Okay, back to our topic. Business middle office resides in big data enabler. This is the big data. The purple one is the big data enabler. With the combined power, business middle office is ahead of the cloud operating system, the big data platform. So with the combined power of digital intelligence from DMO, data middle office, it harvested the business platform, and it's harvested by the AI middle office. See, there should be arrows here and arrows here from AIMO to DMO and from DMO to BMO. So the combined power of data intelligence from DMO and the modularized business components from BMO here and here can the enterprises achieve the most agile innovation. For instance, Alibaba helped Freshippo build its IT system. Freshippo, this one, within 4 weeks. When entering Southeast Asia market, it took only 6 months for Alibaba to rewrite Lazada's IT system. Lazada was, if memory serves me right, Lazada is an Indian company. And before Alibaba take over the Lazada's business, it was the largest online retail platform in Southeast Asia. Okay, let's see today's agenda. Okay, we have 4 topics. Let's move forward. So, as we know, and Alibaba puts it himself, BMO represents a modularized business components architecture, which I think is just another term of FaaS, function as a service. As some samples here indicates, this is a city commercial bank in China. I don't want to say what's its name. The part of its business is reside on business middle office. It consists of 12 business centers from transaction marketing, client equity, payment, to configuration, log analysis, and the basic services like messaging, caching, etc. Each center has its own modularized components like deposit, loan, consuming services in transaction center or the trading center. Yeah, and components can be invoked across business centers. Say the components here can be invoked by other centers. Yeah, in the BMO. In the next case is internet bank. Uh, yeah, and it took one step further than the city commercial bank in China in the previous slide. Um, in this case, after recoding the monolith application to microservices, this bank we call it X bank. Okay, the X bank dockerized them. See, um, all microservices run in Docker containers. So um, so it's after the monolith application was break down into microservices, uh, they lift and shift the VM instance to container instances. They re-architecture the application layer, right? And I'm always being asked whether container is a must to microservices. In brief, microservices tears apart an application horizontally so that different development teams can focus on different features, while container break down an application vertically so that different operation team can maintain different layers of an application. Say OS operation, runtime maintenance, and coding work. OS operation is mostly maintained by the operation team, OS operation team, and runtime maintenance maybe by the program team, and the coding is maintained by the developers, right? And the last case is another internet bank. We call it Y Bank. This is the largest, its largest stakeholder is Alibaba, so which implies its architecture resembles the four enabler architecture in the previous slide. However, there's one point indicating BMO is beyond the microservices, as it groups microservices by functions. This is how we run business, right? So I should say BMO is more business on a business perspective than a technical perspective. So I should say that BMO is uh, since it groups the microservices by functions, so we can say that BMO is more close to the business. In that case, we can assign a bunch of services to a certain department slash BU. Besides, services in the same group may call each other more frequently than across groups. We can define business rules on group base, and the last, uh, some technical components can be shared within groups, like API gateways, message queue services, etc. Next, let's see how BMO gets developed or get evolved in China. Actually, it's a mystery to me that there's no BMO outside China. So, what do they call BMO in countries other than China? I would say that BMO is somewhat the serverless architecture in global terms. Let's take a retrospective on how it evolved over history. I've been working in this industry for over a dozen of years. At the very beginning, before 2008, each application was a server. All of its features were tightly coupled. What makes the uh, the tight coupling makes the integration test very difficult. You can always see lots of legacy monolith applications, which rarely, seldom, scarcely upgrade over years because as long as we change the application, then the um, system or the hardware layer will be affected, or or if we change add let's say RAM, add a 4 GB RAM to server, then it might affect its application and operating system. So whenever we do change in the lower layer, the upper layer applications will be affected. So this is what we call that monolith application. And after that, I see maybe in 2010, the SOA come into place. An application in this age, the application is designed and built in a way that its modules are integrated seamlessly and can be easily reused. The most common component in SOA architecture is ESB, Enterprise Service Bus, which acts as a communication center by allowing linking multiple systems, applications, and data, and connects multiple systems with no disruption. ESB naturally separates the enterprise applications into two roles: the service provider, the service provider and the service consumer. This is the service provider is on the lower side, and the service consumer is here. And since each application or the service is an independent unit, it's easy to update and maintain it without hurting other services. So it's much easier than when we were maintaining a monolithic application. So, for example, large enterprise applications can be managed easier when broken into services, right? And in the year 2014, Martin Fowler defined and published the microservice architecture style. In short, it is an approach to developing a single application as a suite of small services, each running in its own process and communicating with mechanisms, often an HTTP resource API. Sorry. And the architecture further breaks down the applications, not just the reuse common technical components, but in a business perspective. Okay, later, with the development of microservices and public cloud, the cloud service providers started to build and expose all-in-one API to hide its background logics from customers, and also to make the front end inbound traffic more straightforward. Just only need to have all-in-one API, just one open API to the internet, right? It's like DNS recursive queries. The client hits the DNS server once, and all the relevant tasks were accomplished within the system. So within one request, for instance, check no matter what hotel price per night, the all-in-one API responded to the customer with the nearest this hotel, its availability, its paying options by credit card or by debit card, by PayPal, and available coupons. How this API negotiates with other systems and collects all this information is hidden from the customer. And also, they don't need to know this, right? So this is what I understand the development of BMO, or to the global world, the development of serverless. Okay, BMO is so that's how I get the conclusion. BMO is quite like the serverless architecture. It just has one API disclosed to the customer, like Instagram. It's a lightweight applications, right? It leverages most of its features on AWS. For example, image processing and data labeling. So you don't see how the system process your image. You just upload it, and bam, it's finished. And also Netflix, it also takes advantage of stream processing from cloud service provider to achieve flow control and dynamic pricing. So just one API and do all the things because it calls the functions at the backend. Okay. BMO is always compared with TOGAF architecture. In TOGAF, enterprise architecture consists of business architecture, application architecture, data architecture, and at the bottom, technical architecture. As a whole, it serves the enterprises, customers, compliance requirements, and ever-changing technologies which may bring about new business models. Application and data architecture run in the middle of an enterprise architecture. It's quite much the same as middle office. That's why it's called middle office. However, the application architecture covers DMO, since the application in DMO should also follow enterprise application architecture as well. But the data architecture doesn't necessarily cover BMO, since the system in business middle office only have its connected databases for each application. All the ETL or the data processing or data integration work across application is processed in DMO. Some may say that TOGAF is an old story. We'd better compare BMO to some modern application architectures. So this framework is Frost and Sullivan defined the modern application architecture. It consists of architecture components and practices. So I should say, regarding the architecture, the modern application architecture here referring the BMO covers APIs and microservices, but not necessarily using container. That's to say, BMO focuses more on decoupling features from the business than on extracting coding from platforms. So container is not a must. It focuses on decoupling the businesses on a business perspective. So it's horizontally, not separate an application vertically. So container is not a must. And regarding the practices, all the features follows in agile maintenance. Each feature is maintained in its own life cycle. However, the development and operation, or the DevOps, may be separated in most companies, which means the continuous DevOps cycle may be divided into a continuous dev cycle, including continuous build, continuous integration, continuous testing, and continuous delivery. And the other one is ops cycle, which involves continuous monitoring and continuous updating. Different features are developed by different teams. Since features are loosely coupled, the version iteration can be maintained within each single team. So that's to say, DevOps is not a master to BMO, but continuous development or the agile is a factor in BMO. So, and the last but not least, since BMO is per my viewpoint, is mostly applied in financial businesses in China, like the three samples I, I put forward in the previous slides. So the security should always be taken into consideration. Okay, the last topic, what's the future of VMO? We can see kind of the trend from previous slides. That's more agile, more closer to business. This is the application architecture's trending, right? So for the clients, the front end service will be more and more highly integrated, or one click can return the customer all the information required. To support this all-in-one multi-touch point front-end application, there might be thousands of APIs in BMO. So the automatic scheduling and managing across these APIs will be hot topics in the future, or the RPA. What I see current technical to accomplish, to fulfill that is RPA. But I cannot assure if they're, because there are always booming technologies in the market. Second, we can see more and more visual programming tools coming up in the market recently, like Python Flow Scratch, Simple Rockets. So that will give us more, uh, user-friendly development experience. This workout here, you know, it involves many elements. You just drag and drop them to this diagram, and the flow of the application is just easily accomplished and easily understandable. So after using this, I think customers can deeply participate in the application development. They just drag and drop all the APIs and use these threads to make it a whole business workflow. So then the application is easily developed. And I should say that this kind of development is more customized and specific to users' requirements. Who knows the user's requirements best? It must be the user himself, right? Okay, this is what I see, the two trends of the BMO's future. Okay, and that's all for today's video. Thanks for watching. If you like it, please give it a thumbs up and don't forget to subscribe. See you next time.